Hello, everyone, or good evening, or good afternoon, depending on where you're joining us from. My name is Sam Nasser, and this is the Cleveland C# user group. A little bit about the group. We meet every month. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. This platform really serves as a stage for everyone to showcase their skill set. So we gather speakers from all over, and if you're interested or have a topic in mind that you'd like to present, please feel free to reach out to me. If you're interested in finding out future topics, everything is going to be posted on meetup.com at the link listed at the bottom of the slide. Every month we have some giveaway prizes thanks to our sponsors, PostSharp and DevExpress, for sponsoring the post-meeting giveaways. We'll be using the eval forms to raffle those off. Also like to thank the .NET Foundation for sponsoring the Meetup site. And last but not least, NIS Technologies for sponsoring the virtual meeting space. In addition, we'd like to thank Manning.com for a 35% off a selection of books with a discount code, and the link will be made available in chat shortly after the presentation. Some general information. First and foremost, please keep in mind that participation is encouraged, and the only stupid question is the one not being asked. So feel free to jump in with any questions or comments at any point in time. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. So overall, we want to keep it casual but organized, so feel free to chime in with any comments or questions, but at the same time, we want to give enough time for our presenter to go through the presentation and the slides. Last but not least, the presentation will be recorded and will be posted on YouTube. So for tonight's feature presentation, we have Rob Richardson, also known as Rob Rich. He is a software He's a software craftsman in ASP.NET, Node, React, and Vue. He's also a multi-time Microsoft MVP, published author, and frequent speaker at conferences, user groups, and other community events. You can learn more about Rob at robrich.org, and you can also find him on Mastodon at robrich at hikaderm.io. Did I say that correctly, Rob?
I don't know how to pronounce it either.
Fair enough. And so with that, let me turn it over to Rob, and I will go ahead and make you presenter.
Yeah, today we're going to talk about .NET testing best practices. There are no slides in this talk, only code. We're going to live code pretty much everything we see tonight. Now, the code that we're going to see is up on GitHub right now, github.com/robrich/nettesting xUnit MOQ. And we have a done folder representing where we'll get at the end of today. And we have a start folder that doesn't have any tests yet. Now, I did create the project inside the content that we'll look at today, but you can start with the start folder and you can build up to the done folder and then compare your solution with mine and see where I made mistakes. This code is available on GitHub right now, but an easier way to get there, head over to robrich.org, robrich.org. Click on presentations here at the top, and here's the Cleveland C#.NET user group, and the code is available up on GitHub right now. While we're here on robrich.org, let's click on About Me. Thanks for the introduction. Here's some of the things that I've done recently. Both Microsoft and Docker have given me some awards. I'm a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Cleveland or wherever you're watching from, hit me up on any of the socials or send me an email, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I've written a few books, SQL Source Control Basics, that's really fun, and Pro Microservices in .NET 6, just as applicable to .NET 8. It's about architecting in .NET. One of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comments in the air, and they sent me a mug. Woo! And if you'd like a .NET Rocks mug, no, I'm just kidding. So let's start where we'll begin. Now, I've opened the solution inside of Visual Studio, and this is a light controller. It's a piece of an IoT solution that allows us to be able to watch for changes in motion and turn on or off an IoT light. So we have this light switcher. Now this light switcher isn't stateful, so I may turn on a light that's already on or turn off a light that's already off, and that's fine. And then I have this motion sensor that will detect motion. And then I have this light actuator. This is the class that we're going to test today. Now, this is the business logic of this application that does the, should I turn the light on or off? So we'll pass in motion detected. And based on motion detected, we'll set the last motion time. And then if it's dark and I saw motion, then I'll turn it on. Or if it's light, or I haven't seen motion in long enough, then we'll turn it off. And so that's the, we also have a get time period that will, given a date and time, help us know what time of day it is. And so this is the business logic that we want to test. So the first thing that we'll want to do is add a new project. I've already done this. We can say add new project, and then we might choose to pick an MS test one or an NUnit one. In my case, I chose xUnit test project, and so I already created that project. I also added some dependencies to this project. xUnit was already included, but I also installed Fluent assertions and MOQ or MOQ. We could also use nsubstitute as well. So now that we have that content in place, let's build a new test. Now in both NUnit and MS test, we call this test, but in xUnit, we'll call it fact. Okay, fine. Assert dot true. Okay, we've built a test. Now let's see if we can run our tests. Well, we'll come here into the test window and we'll choose the test explorer, and that pops up this window down here. And we can see from this window, we now have the ability to look at our tests. Now it's going to look through our project and notice the test that we have. We can click run all tests, and now it'll do a build. It discovered our test, and then it's going to run our test, and it looks like our test passed. Well, it's not passed yet. It's building. It's building. Go. Okay. Yeah, the first build of the day. We need to wake up the gerbils. So we've got our test. Oh, I probably should have built first. Okay, did my window freeze? Nope. Building. This may be a very different build completed. Okay. Let me build myself and see if that'll get us unstuck. Build started. Oh, maybe it's now queued behind the other build. There we go, build succeeded. Now let's come here to the test explorer and we'll run our tests, and we can see that one test passed. Oh, there's our tests running. Excellent, we've got a green test. So now let's step into this test a little bit and learn a little bit more about what we can do. And I'll introduce the arrange, act, assert pattern. Now the cool part here about this arrange, act, assert pattern is we can set up a condition, and then we can test that condition, or then do the work and then validate that it works as expected. So I'm going to say int actual equals x, int actual equals x plus y, and so we can kind of test drive this test. So in this case, it'll just add things, and then I want to say expect, actual dot should be expected. Okay, now we've done our assertion. And so now what do we need to set up? Well, let's say int x equals 2, int y equals 2, and int expected equals 4. Okay, we can now run this test and we'll see that this test still goes green. Now that's an interesting thing. We were able to test drive this. We built our act first, and then we built our assert, and then we built our arrange. Now in this case, maybe our test isn't real great. It doesn't have great data here, because if I were to change my implementation, my test would still pass. 2 times 2 is still 4. So let's change our data to be more unique so that we can validate that it will add correctly. 2 plus 3 should equal 5. And if we come back here into our test explorer, we can rerun our tests. And now we see we have a failing test instead of a passing test. Now that we have a failing test, now it's really great because it will show us the line number that it failed on. Wow, these builds are taking a while. So here it shows us that one failed, and we can see that we expected it to be 5 but found 6, and here's the stack trace of how we got there. Okay, yeah, let's fix our implementation to plus, and we can rerun our test, run test, and we'll see that it now succeeds. Now, one of the reasons that I really like Fluent assertions is that I spent a really long time with an assert dot equal expected actual. Oh wait, no, actual is supposed to come first and expected second. And so I spent a really long time trying to debug this test where it says expected 7 but got 5. So I debugged it and I got 7 too. Well, it expected 7, I got 7, therefore it should pass, right? Well, actually, I did have these right the first time. It's expected and then actual. And that's why I don't like this assert dot syntax. Instead, with Fluent assertions, actual dot should dot be expected, we can see that it just naturally flows. It's a sentence. And so I really like the Fluent assertion library. Now, the cool part about Fluent assertions is you can use it with any test framework. Manifest test, NUnit, in my case, xUnit, or any other test framework. At the end of the day, an assertion framework will just find a condition that it doesn't like and throw an exception. So we could just write our own assertion library just by testing things and throwing exceptions. Okay, so we built a test. Here's our one test. Now, in this case, we ran it from the test explorer, but we could also run it from the command line just with .NET test. Now, if we run .NET test, it will do the same thing. It will validate that the build is current, and then it will validate the test projects. In this case, it will look through the entire solution looking for test projects. And we'll use this if we have a moment to rig up a DevOps pipeline. So .NET test is going to run those tests, and in this case, we can see that it passes. Or in this case, we can see how long it takes my machine to build while screen sharing. Go, 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 go. Okay, there we go. It built successfully. It's going to run our tests. We can see that we've got one test. Oh, and one test passed. Perfect. So let's take a look now back at our code and see what we need to do. I'm going to create a new file, add new item, light controller tests, and we'll rename that in a second. But let's come back here to this. Now we want to test this light switcher dot, nope, we want to test the light actuator dot actuate lights. So let's rename this. I'm going to rename it to light actuator actuate lights tests. Now that's naming this class this way actually is beautiful in that now we know exactly the class and method that we're going to test. That's a really great best practice here. Let's change this to public and file scope namespaces for the win. Now we have our tests. Now what tests do we need? let's take a look back at our suite under test and take a look at the code that we want to look at. Well, if we pass in motion detected, we want to know that it updated last motion time. Okay, so motion detected, update last motion time. And the other one, motion not detected, don't update last motion time. Okay. Next, we want to take a look at this. So let's say if dark and motion turn on, if light and motion, if dark and no motion don't turn on, if light and motion don't turn on. These are tests that we might want to write, and we can take a look at this one as well. So this one is if light and no motion long enough, turn off. If light and motion, no, if light or if light, turn off. If no motion long enough, turn off. And we can do the opposites as well. If not light and not long enough, don't turn off. Cool. So we have a good suite of tests now. Let's take a look at each of these tests and how we might build this out. Any questions so far? The should and be methods, are those coming from fluent assertions? Yes, they are, Eli. Good call. Okay, any other thoughts or questions, comments while we're here? Public void motion detected, update last motion time. Okay, there's our first test. I do want to attribute it with fact here, so it'll run the test. And I'm going to say throw new not implemented exception. Now, I very specifically do this first because it would be really easy for us to not implement the method and then the test passes because it successfully does nothing. So let's do that. I'll come in here. Let's also build this one. Motion not detected. Don't update last motion time. Great, next test. If dark and motion turn on. And I'll actually bundle that together. We'll come back to that. Here's another one. If light and motion, if light, turn off. If no motion long enough, turn off. And we can also do the corollaries of that as well. Cool. So now we've kind of built out our test suite. And one of the things that we like to do is red, green refactor. So we just did the red piece. Now, if we build and run our tests again, we can see that, of course, all of these new tests are going to fail. And they're going to fail because we haven't written it yet. But let's hit that red first so that then we can make them green and then refactor. Excellent. We've got all red tests. Will I get into mocking frameworks? Yes, I will. Great question, Dave. Nice foreshadowing there. Arrange act assert. Now, what do we want to do? Well, we want to come here and create an instance of this light actuator. So let's do that. We'll say light actuator equals new light actuator. And then we want to call light actuator dot actuate lights, passing in motion detected. And so it looks like we need a motion detected. Let's now assert this. We want to say actual dot should dot be expected. Now, what's the expected? Well, so bool motion detected equals true, and date time actual should be, I don't know, new date time 2001. The date is not important. Actually, the date, this is the setup date. This setup date is not important. It's just something that is long enough ago. So let's say value not important, just old enough. And so we'll document that. I actually even like to put a space there to say, here are the things that I care about, and here are the things I just need to make the interface work. So how do we get actual? Date time actual equals light actuator dot last motion time. Well, that's private. Now here in the application code, we have last motion time, but it is private. We do have an interface, which is good, but let's make this public, not part of the interface, just part of our class, and we'll mark that as so. Public to be testable, not part of interface. Now, we did need to change our implementation to be able to test it this way, but that's one of the things that evolves as we do this. Okay, so now that we have a last motion time back in our test, we can come here and say, as we're doing our thing, light actuator dot last motion time is setup date. And so what I want to say is that it updated. I don't know what UTC now is. We could talk about abstracting that away, but maybe actual should not be setup date. Cool. I think we built a test that'll work. Let's try this out. Now, previously we've come to the Test Explorer and we've run all of them. In this case, we only want to run this one, so we can just right-click on it and say Run Tests. It will then build and run just that one test to help us know if this test will go red or green. Now, we do see a little icon right here that is red, noting that that test failed previously, and we'll see it go green here. There is a mechanism where we can also get it to rerun our tests every time we build. Here in the Test Explorer, and let's zoom in a touch, we can see here in this menu option, we have an option to run tests after build. Now, if your tests are really fast, then you might choose to turn this on. And it's kind of a watch-like experience that you would find in other frameworks, where anytime it builds, it'll rerun the tests and you can get some really good feedback. Now, there is a feature inside Visual Studio called live unit testing. This is not it. This is part of the community edition where you can just run tests after build. It looks like our test went green. Woohoo! We know that our system works in this one little piece. That's awesome. Okay, so now let's do the next test. Now in this next test, it's really similar. So let's go grab this and we'll set it there. Now in this case, motion should not be detected. And so I want my time to be exactly the same. Let's run this test. And now we can see that this test passes as well. Now there is a little bit of duplication there. We could maybe abstract this away, and let's come back to that as we do our next test to be able to see if we can parameterize these tests and make kind of a one meta test that will help us accomplish all the things. Oh, so our build succeeded. Is it going to flip over to the test runner? It is. Why did we get a failure? Light switcher not initialized. Light switcher not initialized. Now, the code under test is this part right here. We just wanted to test this piece, but it's telling me the light switcher is not initialized. That has nothing to do with my test. I want this to go away. Yeah, we have a light switcher, and our light switcher implementation kind of has this strongly typed interface, this singleton pattern, and yeah, we haven't initialized it yet. Well, that has nothing to do with my test. Let's see if we can refactor this to maybe get away from this singleton pattern. So I'm going to create this light switcher, and I'll just come delete this whole instance class. And now here in my light actuator, I can take in a light switcher. Now I'm using the C#12 syntax here. We could definitely use the previous syntax where we say public light actuator and create a constructor, and then take in that light switcher and create a public private field for this. Private light switcher. And then say this dot light switcher equals light switcher. And that syntax, it definitely works. And if you're more comfortable with that, then you can definitely do it that way. But I kind of like the new C# syntax where you can just put it right there. And it does exactly the same thing. It creates that private field and allows you to inject it into your class. This, by the way, is called default constructors. So now that we have this light switcher interface, we can use that light switcher interface instead of this instance, and then we now have that dependency injected into us. Now we do need to go modify our production code. Here's a production code that just kind of sets up the things that we need. So now we'll have an light switcher equals new light switcher, and now I'll pass that into there. Here's my light switcher. Oh, I moved the interface outside that static class. Cool. So now that we've injected in our dependency, then here in our test, we need to be able to pass in that dependency. Okay. Now let's reach out for mock-u. Now the cool thing about mock-u is we can create this mock that implements an interface. Now we could definitely implement a fake interface and talk about how we could build this up, but at this point, I don't care. I just want this thing to work. So instead of creating a fake interface, I could say, public fake light switcher, and then I would need to implement the interface, and that might get kind of heavy. Instead, I'm going to create a mock. So let's do this. Mock of light switcher. Light switcher equals new mock light switcher. Cool. I'll even create a new section called mocks. And now this is a thing where I can see how many times it's got called and maybe override various behaviors. And the actual implementation is light switcher dot object. And so that's the interface that this thing needs. Okay, so let's do that over here as well. And now we have that mocked dependency. So now when we run this test, we can see, let's build first. We can see that now that fake thing, it will just implement all the methods and it'll implement all the properties, and that will just melt away, which is really nice. Run test. And we can see that now that test will pass. Now that was a really, really fast run through mocks. Any thoughts here on mocks, fakes, stubs, our implementation of it?
Can you do a comparison, contrast between the three you mentioned?
MOQ is the one that was a great question. What's the difference between mock and substitute? There was Rhino mocks and a whole bunch before this, but mock and substitute have kind of become the de facto standards. Mock is kind of the one that has taken the majority of the market share because you don't have magic strings here. You just create an interface and away it goes. But it does now have a bad reputation because they started including spyware in the app. And so the world is kind of moving towards substitute. And I haven't yet updated this presentation to do that. But for the most part, this experience with mock is pretty much the same as substitute. The only difference in substitute is that you actually pass in the light switcher itself, not the .object of it. As we get to setting up fake methods, I'll also show you one other difference between the two. Spyware in MOQ, yes. They have walked back from this, but they started including a thing that was meant to congratulate you for supporting open source software, but they were posting your Git email address off to their servers, and people really didn't like that. I can see why. Okay. Our next step here is this if dark motion turn on, if dark and no motion don't turn on. And so we can see in this application code that we have evening and night. So what if we could kind of create one meta test that flexed all of these different things? So I'm going to come back here into our test and let's say if dark and motion turn on, I'm going to take in string time of day, bool, expected, should we have turned on? Okay, so let's do this arrange, act, assert. Now in our act, we want to build up our light switcher. So let's come here into our light switcher and build that up. I'm not sure if we do need an iLight switcher to put that in, but our setup date is not super important. We just need to know that if motion was detected, that it turned on. So let's set our setup date there. Bool motion detected is true, and that's a value that we do care about. And so we want to assert, we're not after that, we want to say turned on dot should dot be expected. Now how do we get the actual turned on? Well, we know here in this we have this light switcher dot turn on. Okay. Now we have this fake light switcher here. Let's set up that dependency. So let's say light switcher dot setups, and we'll give it this lambda m dot turn on, and we want to do a callback. So what happens when we do this? Well, if you set up that thing, then we want to call back this function. Okay, so let's call back. Turned on equals true. Okay. So bool actual turned on equals false. And I see I renamed it on the way through. Cool. So if this code calls the turn on method, it will call this turn on method and call this callback, setting this value to true. Then we can validate that it should work as expected. Now we need to do these parameters. So we'll change this from fact to theory, and then we'll say inline data. So we can say evening, true, and night, true, and morning is false. And let's go look at this here, night, morning, afternoon, evening. Afternoon, we're going to assume that it's still light out. So let's say inline data, afternoon, false. Cool. We just now set up one test that will do all 4 of these conditions at once. That's perfect. Yeah, if we wanted to, we could go refactor these 2 tests to be the same, but let's leave that be. So if motion was detected, if light and motion don't turn on, there we go. So we now have one test that can do all of our things, kind of. We haven't used time of day yet. So let's take a look at that. Well, how do we get time of day? Well, we have this time period here from this get time period. So does that mean that we have to take control over datetime.now? That isn't really what we're trying to worry about. What we're trying to worry about is this get time period. Now, right now, this get time period is a private method inside this class. Let's see if we can extract it out into a different class so that we can fake it and be able to use it within our application. So let's say public class time period helper. And yes, if I was doing this correctly, I would probably move this to a different file. Public interface time period helper, and that interface has a public string get time period date time. And so now time period helper can implement time period helper. Excellent. Now into my class, I can say, well, let's take in an time period helper. And then rather than using the built-in method, we'll use the time period helper dot get time period so that we can take more control over it in our test. Perfect. So here, let's set up a new mock of time period helper, and then time period helper dot setup. And so if you call get time period, then I'm going to return the time of day. Now we do need to pass in this parameter, and based on how we do this, that parameter might be any date time. I don't want to have to worry about what date time it is. So I'm going to use mock's helper it.isAny date time. And so now if you pass in any date time to this method, it will correctly return this time of day. Now these tend to get a little bit lumpy, and so oftentimes I'll extract them into another method where I can call it. Let's come back to that. But for now, I'll just leave them here. So, okay, now we pass in the light switcher object and the time period helper dot object, and all should be well, right? Yes, you're right, Michael. The author of MOQ has walked back quite a bit. The web server no longer gets posted the email, only a hash of the email, and he's made it much more obvious, open sourced all the pieces. So yeah, I would say maybe nowadays the harsh treatment of MOQ is probably too much. Okay, so we built it. Now that we've refactored this time period helper into a different class, oh, we've got a build fail. How did our build fail? Well, let's take a look at our program.cs. Oh, yep. When we implemented this, we now need to take in a time period helper. And so we would have to say, well, let's create a new time period helper. Hey, couldn't we, I don't know, use dependency injection for this? Yes. Now, this class wasn't set up with dependency injection, but we can definitely do that on our own. So first, we'll create a new service collection. Var services equals new service collection. And then we can add our singletons, add our things into the IOC container. And so we'll add each of those into place. And then var IOC equals services.build service provider. And then let's go grab the one that we need. Our light controller, we can say IOC.get required service of type controller, and all of the rest of this code just kind of melts away. That's cool. Now we did this by hand this time, but if we're using MVC or Web API or even minimal APIs, this IOC process is built for us, which is really nice. So we can just add another piece into our IOC container and we're ready to go. Let's build again. And I think we've got a new thing ready to go. Oh, In our old tests, they also need that dependency. Well, we got tired of doing this with our dependencies for our application code, and we used an IOC container. Can we use dependency injection here for our unit tests as well? And yes, we can. Here is a, oh, this is how we might rig up dependency injection with, we do need a reference to Microsoft Extensions dependency injection. And then, yeah, we just build up our service provider, add our things, create a logger, and away it goes, thanks to this blog post. So now let's take a look at dependency injection with tests. Well, AutoMocker is a really good way for us to create this IOC container, and then we can create an instance of it, and it will just automatically mock all the things that we want to worry about and not mock. And if we provided a mock, then it can use the mock for those things that we provide. So let's come back in here and say, well, I really don't care about that mock in this test. So let's just say var IOC equals new auto mocker. And then I'm going to say to the auto mocker, IOC.create instance of type light actuator. And it will go figure out what dependencies it needs and automatically rig those up. Excellent. So let's do the same thing now with this test. Oh, yep, let's go grab our IOC container and set it there, and grab our creating the instance and set it there. And now how might we do this with this one where we have a whole bunch of setups? Well, there's two different ways that we can do it. First, let's set this in place of IOC.create instance, light actuator. Excellent. And now we can just say, after we've built this thing up, we can say IOC dot use light switcher, and now we've got that mock set up. The other way that we can do it, and the way that I like to do it, is IOC dot get mock of type I time period helper, and that will automatically use it. Cool. So now we've used dependency injection inside of our test in the same way that we use dependency injection inside of our actual code. So if we run all of our tests now, we can see that we've got not only these 2 passing tests that we had, but we now have 4 more passing tests focusing on the things that we want. That worked. Let's come in here to our test explorer, and we still do have a bunch of not implemented tests. But now we have 4 new passing tests validating that if any of this time of day happens, we will get the correct answer. Excellent. Any thoughts or concerns about that one? Ooh, is AutoMocker dependent on MOQ? Yes, it is. There is an AutoMocker associated with NSubstitute, but this AutoMocker is very specifically spitting out mock MOQ things. It's actually in the MOQ repository. Great question, Eli. Okay, so that was really cool. We built up a whole lot of tests really quickly. Let's do a similar thing for if it's light. So here in our application code, we can say if it's been long enough or it's day, then we should turn it off. So let's see if we can make it light, then we'll turn it off. So I'm gonna start there. If light, turn off. So now we've got the time of day and the expected. And so now in the evening, we should not turn it off. At night, we should not turn it off. In the morning, we should turn it off. And in the afternoon, we should turn it off. And the important piece here is that the last motion time is greater than a minute ago. Okay, so we do want to say motion was not detected, and this is more than a minute ago. Excellent. Now here we're not grabbing the turn on, we're grabbing the turn off. And so let's change this to actual turned off. And I think we've got a test pretty much ready to go. Let's fire this off. Build and run test. Our build is going, build succeeded. Let's run this test, which by the way, will run all 4 of those instances. I love that part. Test Explorer. It looks like we've got some bugs. Some of them worked, but some of them didn't. Let me take a look at that. I'm going to set a breakpoint right here, and let's right-click on this test and choose to debug the test instead of run the test. Now, I don't know what time of day we're going to get, so we may need to skip over some things, but let's get to one of those that failed, evening or night. Okay, got our build fired up and we're debugging. We've set up all of our mocks and now we're ready to start doing the code. Okay, what is our time of day? Our time of day in this case is busy. There we go. Our time of day is night. Perfect. So let's F11 to actuate lights. Was motion detected? Motion was not detected. Good. So our last motion time is still a long time ago. Our time period helper, we got night. We injected that in. If we want to watch this, this can be really cool. Let's step into F11 and, oh, it jumped over it. We'll actually step into the MOQ instance, which is really cool. So was motion detected? No. So now, has it been long enough or is the time period night? Okay, so I would expect it to turn off and we can see that, oh, actual turned off is true. Excellent. And so now back in our test, well, what was expected is false. So it looks like I may have that flag backwards. In the evening, in the morning or noon, it should turn off. Oh, I bet last motion time is greater than 1 minute. Yes. So I want to say this is less than a minute ago. Okay. So date time dot now dot add seconds. -10. Hopefully my test won't take more than a minute to run. And let's run these again. Run tests. And now we can see, as we were able to debug that test, we can get more of a feel for that. And now we'll see that that night will go green. Oh, it looks like afternoon is not green though. Let's see if we can test that one. Okay, so let's come in here. Let's debug this test again. Debug test. Now I love that we can use tests to be able to validate the behaviors of our system, maybe even to build the features of our system if we're using kind of a TDD methodology. But let's take a look and see if we can use our tests to be able to find bugs. Okay, so let's step into this. And what is our time period? Our time period in this case is afternoon. Oh, nope, we're in the wrong test. Let's come back over and see if we've got our time of day. This is afternoon, perfect. So let's come in here to afternoon and we can see that we've got a time period of afternoon. And now we go check and no, we didn't. Oh, we're not checking for afternoon, we're checking for noon. I think we have a bug in our code. Now we could definitely just fix it to say, well, you know, this should be afternoon and now it would pass. But really what we've noticed is that we have some magic strings in our system. Let's see if we can move away from these magic strings to an enumeration. So here we have a time period. Let's say public enum time period. And in this time period, we have night, morning, afternoon, and evening. So now, instead of returning a string, let's return a time period. And we'll do time period.night, time period dot morning, time period dot afternoon, time period dot evening, and then now in our class here, oh, this returns a time period now too, and this returns a time period. We can now check this for time period dot evening, time period dot night, and time period dot noon, and time period dot morning. And now, oh, look, we have a compile fail. And so that helps us discover this. This is actually afternoon. Now, the cool part about this was that time period was an internal piece of our former class. So we don't need to modify anything in program.cs now that we have a different interface between our new time period helper and our light controller. That's great. But we do have some tests to fix up because, well, this is now a time period and this is now a time period. So let's change this to time period. And in a second, GitHub Copilot is going to notice and it's going to help me with this. Or maybe my machine is just too overloaded and it won't. So now let's update these time periods here and these time periods here. And now we can see that we've got much more strongly typed definition between these two pieces. Excellent. We used our tests to be able to find a bug in our code that really wasn't obvious without these tests. We would have been like, why is my light not turning off? Yeah, let's run all of our tests again and validate that all of these turn off tests now go green. Yes, excellent. So we just did a whole bunch of tests to be able to validate the majority of our code. We tested the time period, we tested this time period, we mocked out get time period. Now the next thing that we want to test is this from minutes. And I want to show you a DevOps pipeline instead. So I'll leave this to the reader to be able to take a look at this. Now, one of the clues that I'm going to give you is that here it's datetime.now. How might we mock out datetime.now? How did we do it when we had a get time period method? Maybe we need to build a mechanism for getting the date time in a dependency that we can pass in. Cool. So we have each of these tests, and other than the one that we didn't implement yet, we can see that they all pass. Let's go build a DevOps pipeline. Now, the cool thing with DevOps pipelines is that we saw here, we can just run .NET test after we run .NET restore and .NET build. And so let's build up a DevOps pipeline that will do exactly that. So we can come here into our project, and if we come into actions and we don't have one set up yet, then it will actually give us prompts for how we can create a new workflow. Now, in this case, I already have the workflow set up, but that file is here inside of, oh, actually, let's open it up right here. In our, oh, we'll look at it inside of our repository. That'll be great. When we create a workflow inside GitHub Actions, it goes into the .github/workflows folder, and we'll take a look at that workflow. So I said that I would like to do it on the main branch and on pull request branches. I have workflow dispatch turned on, which allows me to push a run now button rather than having to change something just to rebuild it. And after I check out, then I will go into that done folder, .NET restore, .NET build, .NET test, and that will be able to run those unit tests. Now, I did add a logger. So I Googled how do I add this logger, and it says use this JUnit test logger NuGet package. Okay, so I added this logger dependency into my thing. Here's my, oh, I didn't I didn't add it in the one that I built yet. Let's come back into here and we'll take a look at the CS proj for the done file. I added in one more dependency, this JUnit XML logger, which will grab the test results in JUnit format. Now, JUnit format is typically used by Java, but it can be used by anything. It's just capturing test results. And the cool thing about that JUnit test logger is I can then pipe those JUnit test results into anything that understands those test results. So I could use, for example, this test reporter GitHub action. And this test reporter GitHub action just takes that test result in JUnit format and shows it in the build results. So back in our build, let's come back to the workflow and we'll see that I grabbed that, I put that in results/test results XML, and then I piped that test results XML into this test reporter. Now, one piece that is really important is this if always. If I have failing tests, it will fail this task. And if it fails this task, by default, it will not run this task, which means I won't publish failing test results. So make sure that we do this if always, and that will run those test results into the build results. So let's come here into our build actions, and we'll take a look at a previous build run, and I'll look at the one before that. And now we see that we have these test results. And so it will show me all of the tests that I've written. It will show me that each one passed. It'll tell me how long it took to run each DLL. And if there's a failure, in the same way that I saw a failure in my test runner, I can see the parameters that it passed in and how it failed. So I really like this test results thing. There's also other actions where you can put in quality gates around pull requests, and that can be really fun. There's also some that will show it instead of as a separate tab, it will show it as build results right here, which can be really fun. So the cool part about this then is we started with no tests at all, and we built where we had a whole suite of tests that do some really interesting things to be able to validate all of the pieces of our components. Now the cool part, all of this code is online right now on GitHub. You can fork this project or download it and get a feel for all of the code that we built today. If you're watching this online, hit me up on Mastodon or Twitter or any of the socials, and let's continue the conversation. But for those of us who are watching it now, what are your thoughts? What are your questions? What are places that you would have done this differently?
I think now's a good time for people to come off of mute and just jump in verbally, either that or you can do it in chat. Or you can remain shy on mute and not say anything.
One challenge we have in our business, we're working on now an old web forms application that's pretty tightly tied to database, SQL Server. What would you recommend on how to decouple the database layer from the web form application so we can possibly get this thing more into unit tests without launching missiles?
Ooh. Yeah, so we have an application, a legacy application that kind of has data access kind of mixed in with business logic, and we want to be able to unit test the business logic, but we can't really separate the data tools. I like that. We kind of had a similar thing here with this get time period, and what we created was this separate class that did the actual query into that data store to be able to get stuff. So maybe we can create repository classes that do the actual data access, the actual use of entity framework or ADO.NET to be able to get at that data, and then move those queries out of our code here into these repositories. Now, when we're testing our business logic, we don't have that data access code. We can just pass in a fake repository that will return known results that allow us to be able to flex our business logic in interesting ways. Separating those queries into a repository tier can really help you make the rest of the application more testable. So then the magic question is, well, how do I test my repositories? Can I unit test them? Well, you could, but the purpose of a repository tier is to shim between data storage and application. And so really, you probably want to use integration tests in your repositories to be able to validate that they can correctly connect to your data store and be able to run these queries. At that point, maybe you can prop up a fake data store using GitHub services to be able to run your tests, but that's kind of a bigger thing. Usually, I don't get too deep into testing my repositories.
We have also an entity, I think Entity Framework Core application, and for that we used SQLite to spin up a schema, and then that kind of ran. The unit test kind of ran against that. That worked fairly well, but that one was a little bit better decoupled too for its unit tests. So this is a different beast that we're working on now.
Yeah, SQLite is really good at being able to plop in fake databases.
Okay, very good. Any other questions, comments?
One other question. You chose to use xUnit for this in preference to say in-unit or MS test. Why did you choose xUnit, just out of curiosity?
Why did I choose xUnit over in-unit or MS test? If you step back, for the most part, all three of them have really comparable features. And so maybe you don't need to make that choice. Maybe you could use whichever one you've already used or whichever one you like better. I chose xUnit because when we moved from .NET Framework to .NET Core, it was the first one to get ported. And so the ASP.NET team actually uses xUnit to test ASP.NET. And that was a good enough recommendation for me. I'm like, hey, if the ASP.NET team likes xUnit, I'll like xUnit too. But ultimately, whichever of them or any one that you like, the important part is to be able to write those unit and integration tests. And so use the framework that makes you happy. If you can have a dev server and manage transactions well, when in test, rolling back all transactions can give our team a set of regression and integration tests for a large day import batch processing. Yes, I love the ability to just roll the transaction back at the end of the test. There's some scenarios where that doesn't quite work, like for example, if my test starts and completes a transaction within it. But yes, rolling back transactions is great. The only downside is then I have to reseed my primary keys, or there will be gaps in between them. And if that's totally fine, then yeah, that can be a really, really elegant solution. The other solution is to spin up a database in a container, probably from last night's production backup. And I have a whole separate talk on using databases in containers to be able to facilitate integration testing.
That's also another great idea. Any other questions or comments? Going once, twice. All right. And with that, thank you very much, Rob. Very well done. And great tutorial. It was great to be able to follow along and code with you.
Most definitely. This talk is so much fun, and I'm glad everyone stuck with it. It was really, really cool to get to show you .NET testing best practices.
Absolutely. Really enjoyed it. If you don't mind, I'm going to take back the screen share and just go through a couple concluding slides. And while I'm doing that, if you would please focus your attention on the chat window. I pasted several links that we'll cover at this time. And let's go ahead and do that. So the recording will be posted on YouTube. If you would please subscribe to the channel to get upload notifications. In addition, the tech events that we'll cover in just a little bit will be posted on my blog. And again, you can subscribe to that to get updates as well. And last but not least, the feedback eval form. The link for that is also in the chat. So if you would please take a moment, fill that out so we can give Rob some constructive criticism. For those that joined us shortly after the start of the meeting, we mentioned that there's a 35% off offer on selection of books from Manning.com. Both the link and the discount code are available in chat. Some regional events, specifically user groups. Tomorrow, January 25th, is the Central Ohio .NET Developers Group, and they're going to be meeting online, and they will be covering what is new in .NET 8 as well as Azure. And then on February 6th is the Ohio North Data Training Group, and that is a hybrid group that meets both virtual and in person. And they're going to be discussing how AI could be used to make your job easy. On February 14th is the Azure Cleveland User Group, and that meets every second Wednesday. And on February 17th is the Greater Lansing User Group.net, and they meet virtually as well, and they meet every third Thursday of the month. And then on the fourth Wednesday is the Cleveland C# User Group. So as you can tell, we obviously moved the meetings from Thursday to Wednesday to have less conflict with other user groups. So going forward, the meetings for this year will be held on every fourth Wednesday. One of the things that we always like to do is discuss job openings. So I'd like to ask who's hiring and who's looking for work. So if you would please make yourself known in chat or speak up verbally. Anyone have any jobs available or looking to change? Sam McGraw is looking. Very good. Sam, can you give us a little bit of background about yourself? Are you a junior, mid-level, senior? No problem. We'll wait for you just a second. Anyone else looking for work or have any job openings? Sam, you still having technical difficulties?
Sorry, guys. Thanks for waiting. I'm, I would say I'm a junior programmer, but I'm a hard worker. So I know lots of, pain points. So I would say junior to mid-level, everything on the Microsoft stack.
Excellent. Very good. All right. So if anyone has any job openings, please make yourself known. In addition, you can also reach out to me and I'll have my contact information available. But also check out techsystems.com/IT-jobs. They always have a variety of jobs specifically for .NET available there. And as I mentioned, you can always reach out to me later with job openings or questions in general. My email, snasser@nistechnologies.com. You can also find me on Twitter @SamNasser. The link to my blog once again. And if we're not connected on LinkedIn, I invite you to do so. And so with that, thanks again to Rob for a great and very useful presentation. And thank you all for attending and look forward to seeing you all next month. Good night, everyone.